Giant industrial gears. These silent titans power the world's biggest machines. From the roaring engines of cargo ships to the massive turbines of power plants, they move with precision, carrying unimaginable loads. But have you ever stopped to think, how are these monstrous gears actually made? What kind of machines shape them? What kind of engineering genius goes into their creation? Stay right here because we're about to take you inside the world of extreme manufacturing, where molten metal, crushing force, and laser-precise machining come together to forge the gears that keep our world moving. 1. The raw power of steel. Where it all begins, every giant gear starts with something simple: steel. But not just any steel. These gears don't sit in toy cars or home appliances. They power machines that lift, crush, and move thousands of tons. That means the steel has to be unbelievably strong, resistant to heat, pressure, and wear. So how do they get the perfect steel for the job? It starts with a mix of iron, carbon, and other metals like chromium and nickel. This mix isn't random. It's carefully chosen to make sure the final gear can handle extreme forces without breaking. Too soft, and the gear will wear down fast. Too brittle, and it could crack under pressure. The perfect balance is everything. The process begins in fiery furnaces where raw materials are melted at over 1,500 degrees Celsius. That's hotter than lava. Once melted, the liquid steel is poured into massive molds or shaped into solid blocks called billets. But the journey doesn't stop there. Before this steel ever touches a gear cutting machine, it goes through intense testing, checking for impurities, ensuring the perfect composition, and making sure it's strong enough for the job ahead. Because in the world of industrial gears, there's no room for weakness. 2. Forging the beast, shaping the gear's core. Now that we have the perfect steel, it's time to shape it. But we're not talking about simple cutting or bending. This step is all about brute force. The goal? Take a block of raw steel and turn it into the rough shape of a gear, ready for precision machining. There are two main ways to do this: casting and forging. In casting, molten steel, hotter than the surface of a volcano, is poured into massive molds shaped like gears. As it cools and hardens, the gear begins to take form. But casting alone isn't enough for high-strength gears, so many industrial giants go for the forging method instead. Forging is where true power comes in. Imagine a steel block the size of a small car being slammed by a 10,000-ton hydraulic press. The pressure is so intense that it doesn't just shape the steel, it realigns the metal's grain structure, making it denser and far stronger than before. This is what gives industrial gears their legendary durability. But this isn't a one-step process. The forged piece is repeatedly heated, pressed, and reshaped until it looks like a rough gear, still oversized but ready for the next stage. Strength is built in this phase, and if anything goes wrong here, the gear could fail years later. That's why every press, every hammer strike, and every cooling process must be perfectly controlled. 3. Precision cutting, carving the teeth that move the world. A gear is only as good as its teeth. If they're not cut perfectly, the entire machine could fail. And when we're talking about industrial gears, some the size of trucks, even the tiniest mistake can be a disaster. That's why this stage is all about precision. The forged gear blank is now placed onto CNC machines, giant, computer-controlled cutting tools that shape each tooth with absolute accuracy. These machines use razor-sharp cutters, grinding wheels, and sometimes even lasers to carve deep, perfect grooves into the metal. The cutting has to be flawless. Even a difference of a fraction of a millimeter can cause vibrations, noise, or total mechanical failure. But here's the challenge. Industrial gears don't just spin. They handle massive forces. That means their teeth aren't just shaped for looks. They follow special designs like helical spur or bevel patterns, each meant for different types of power transmission. Cutting these complex shapes isn't easy. It takes hours, sometimes days, with every cut carefully measured and tested. Once the teeth are carved, the gear isn't ready just yet. The steel is still soft, and under heavy loads, the teeth would wear down or snap. That's why the next step is all about making these gears tough as armor. And that's where heat treatment comes in. 4. Heat treatment, giving the gear its superpowers. A giant industrial gear may look strong, but without this next step, it wouldn't last a day inside a heavy machine. Right now, the steel is still too soft. Under extreme pressure, the gear teeth will wear out, bend, or even snap. That's why they go through one of the most intense processes in manufacturing, heat treatment. Here's how it works. The gear is heated to an insane temperature, sometimes over 1,000 degrees Celsius, 1,800 degrees Fahrenheit, turning the metal red hot. At this point, the steel's structure is completely changing at the atomic level, making it tougher and more resistant to wear. But heating alone isn't enough. Next comes the most crucial moment: quenching. The red-hot gear is suddenly cooled using oil, water, or even nitrogen gas. This rapid cooling locks in the hardness, making the surface ultra-strong while keeping the inner core slightly flexible. If this process isn't done just right, the gear could crack, warp, or become too brittle. That's why timing and temperature control are everything. But we're not done yet. After quenching, the gears often go through tempering, a second round of controlled heating at a lower temperature. This reduces internal stress, preventing cracks and ensuring the gear has the perfect balance of strength and durability. Now the gear is no longer just a piece of metal. It's battle-hardened steel, ready to take on thousands of tons of pressure. But before it's put to work, there's one last step: grinding, polishing, and the final inspection to make sure this beast is absolutely perfect. 5. The final touch: grinding, polishing, and testing. The gear has been shaped, its teeth have been cut, and it has been heat-treated to become nearly indestructible. But before it can take its place in a giant machine, there's one final step, the most precise and critical part of the process. This is where flawless perfection is the only option. First up, grinding. Even though the teeth were carefully cut, they still have tiny imperfections, microscopic rough edges that could cause friction, noise, or even failure over time. That's why massive grinding machines use diamond-coated wheels to smooth out every single tooth to an accuracy of a few microns. That's thinner than a human hair. Then comes polishing. A finely polished surface isn't just for looks. It reduces friction, allowing the gear to run smoothly for decades without unnecessary wear. Some gears even go through special coating processes to make them more resistant to heat and corrosion. 6. Where these giants go: the machines they power. Now that the gear is battle-tested and perfected, it's time for the real action. These aren't gears for bicycles or cars. These are the giants that keep the world moving. But where do they go? What kind of machines need gears this big and this powerful? First up, mining machines. Imagine a truck the size of a house, carrying hundreds of tons of rock. Inside, massive gears work together to keep the wheels turning under extreme weight and pressure. Without them, mining operations would come to a standstill. Then there are wind turbines, those towering structures that generate clean energy. Inside each turbine, a huge gearbox slows down the extreme speed of the spinning blades, converting it into the perfect rotation to generate electricity. Without these precision-made gears, the entire system would fail. Next, we have cargo ships, floating cities that transport goods across the world. These ships rely on some of the biggest gears on the planet, transferring power from engines the size of buildings to giant propellers that push thousands of tons through the ocean. And let's not forget heavy industrial machinery, steel mills, power plants, construction equipment. Without industrial gears, factories would stop, power grids would fail, and skyscrapers wouldn't be built.